You connect your scan tool, and suddenly half the modules won't communicate. ABS offline, power steering offline, body control module offline. The dashboard is full of warning lights. Where do you start? Do you replace a module? Replace the PCM? Replace the wiring harness? Absolutely not. In this video, I'll show you a simple step-by-step process that professional technicians use to diagnose CAN bus problems quickly and accurately. Let's get started. Understand the complaint. Before touching the vehicle, ask, does the engine crank? Does it start? Which warning lights are on? Which modules communicate? Is the problem intermittent? Has any recent repair been performed? Many CAN bus failures begin after battery replacement, collision repair, water intrusion, accessory installation, rodent damage. Understanding the history often saves hours of unnecessary testing. Scan every module. Perform a complete network scan. Look for modules that communicate, modules that don't communicate, U codes, lost communication codes, low voltage codes. Keep this in mind, that a short in the network circuit will take the entire network down, while an open will isolate some modules. Create a network map. Example, PCM communicates, BCM communicates, instrument cluster communicates, ABS does not communicate, power steering does not communicate. This helps narrow the affected section of the network. Check battery voltage first. Low system voltage causes many CAN problems. Verify battery voltage, charging system, main grounds, fuse box voltage. Many communication faults disappear after restoring proper battery voltage. Using CAN bus voltage to diagnose the vehicle. One of the fastest ways to evaluate the health of a CAN bus network is by measuring the CAN bus voltages. With just a digital multimeter, you can often identify an open circuit, a short together, a short to ground, a short to battery voltage, or a module that's pulling the network down. Let's see how it's done. Step 1. Locate the data link connector. Every modern vehicle has a 16-pin data link connector, also called the OBD2 connector. It's usually located under the driver's side dashboard. For high-speed CAN, the two pins you'll be testing are pin 6, or CAN high, pin 14, or CAN low. These two pins connect directly to the vehicle's communication network. Step 2. Set up your multimeter. Turn the ignition on, but do not start the engine. Set your digital multimeter to DC volts. Connect the black lead to a known good chassis ground, or the battery negative terminal. Now, begin testing the CAN circuits. Step 3. Measure CAN high. Touch the red lead to pin 6. On many high-speed CAN networks, you'll typically see about 2.5 volts when the network is idle. The reading may fluctuate slightly because the modules are constantly communicating. During active communication, CAN high transitions toward approximately 3.5 volts. The exact reading varies by manufacturer and network activity, so consult service information when available. Step 4. Measure CAN low. Move the red lead to pin 14. You should typically observe about 2.5 volts at rest. During communication, CAN low transitions toward approximately 1.5 volts. Again, small fluctuations are normal because messages are continuously being transmitted. Step 5. Interpret the readings. Now let's learn what these voltage readings can tell us. Normal network CAN high, about 2.5 volts and moving toward 3.5 volts during communication. CAN low, about 2.5 volts moving toward 1.5 volts during communication. This indicates the network is likely communicating normally. CAN high toward at 0 volts. If CAN high measures approximately 0 volts, it may indicate a short to ground, a failed control module pulling the line low, CAN high, near battery voltage. If CAN high measures close to battery voltage, such as 12 volts, suspect a short to battery voltage, wiring damage, a module fault affecting the network, CAN low toward 0 volts. If CAN low stays near 0 volts, possible causes include short to ground, internal module failure, CAN low near battery voltage. If CAN low measures close to battery voltage, suspect short to battery voltage, a failed module. Both wires near 2.5 volts with no communication. If both CAN high and CAN low stay near 2.5 volts, but your scan tool cannot communicate, check module power and grounds. Network circuits is shorted together. Step 6. Use voltage with other tests. Voltage testing is an excellent first step, but it should be combined with scan tool network topology, wiring diagram analysis, oscilloscope testing when needed, module power and ground verification. Professional technicians rarely rely on a single measurement. Real diagnostic example. Let's look at a real scenario. A vehicle arrives with these symptoms: ABS warning light, traction control warning light, power steering warning light. The scan tool cannot communicate with the ABS module. Voltage measurements show CAN high, approximately 2.5 volts. CAN low, approximately 0.2 volts. That abnormal CAN low reading points to a problem on the low line. After disconnecting the ABS module, CAN low returns to about 2.5 volts and communication is restored. The failed ABS module was pulling the network down. Without replacing any unnecessary parts, the fault was quickly identified. CAN bus voltage testing is one of the quickest checks you can perform on a communication network. Remember, measure CAN high, measure CAN low. Typical high-speed CAN networks rest near 2.5 volts on both lines, with CAN high moving upward and CAN low moving downward during communication. Use abnormal voltage readings to guide your diagnosis, but always confirm your findings with resistance checks, module power and ground tests, a scan tool, and, when appropriate, an oscilloscope. CAN bus diagnosis doesn't have to be complicated. When you understand how the network operates and follow a logical diagnostic process, you'll spend less time guessing and more time finding the root cause. Remember, a multimeter, a wiring diagram, a scan tool, and a solid understanding of the system are your most valuable diagnostic tools. Don't replace parts until you've confirmed the fault through testing. If you found this video helpful, please give it a thumbs up, subscribe to Car Facts Garage, and turn on the notification bell so you never miss our latest automotive training videos. On this channel, we simplify modern vehicle technology, electrical diagnostics, and repair techniques to help technicians, students, and automotive enthusiasts diagnose today's vehicles with confidence. Thank you for watching, and remember, knowledge builds confidence. Testing finds the fault.